My name's David Greening. I'm a lab head at the Baker under the molecular proteomics group. So our research is multi-omics. So we understand cell systems, cell signaling, and organelle biology. And that basically means is we understand the heart in really refined and new detail, and circulation. In other words, what's in blood and how we can use it as a therapeutic and diagnostic. The pressing challenge is that heart disease is only increasing. At the moment, it's 1 in 3 patients die, it's 1 in 50 actually die of heart failure. And most of the reason why is that either we're detecting this disease at a too late a state, but secondly is maybe we need newer, better refined therapeutics that can help us interfere and protect and potentially repair, regenerate this at a much earlier point. The heart is a signaling organ, which means it talks to every other organ of your body. It does it through the blood. If we can understand what makes up the blood, if we can understand what makes up the heart, and the two of them together, we can understand how the cells actually talk through these small cell bubbles, then basically we have a completely new way of understanding new therapies that use this signaling strategy or circulating diagnostics. So for the first time ever, we have an ability to isolate, refine, and for the first time understand what these small vesicles are. By understanding something at that level, you can now start designing new ways in which maybe they alter in a disease. They can be used as a signaling tool, or the really cool part is maybe we can combine all of this together and come up with a magic payload that can be delivered to a specific cell or a specific organ when we want. The challenge is still how we can actually get this into a clinic. We may have all this amazing information and innovative research, but the big step for us is still and always focused on getting this to the clinic. The support for our research is always present, right? It's always needed. Donors can impact many different levels, whether this is specific people, to labs, to new ideas that we have, to potentially support new technologies that we really need to integrate and ask bigger questions. So in terms of impacts for both of those areas, whether it's new therapies or new diagnostics, it impacts not only patient quality, patient care, but also huge economic burdens with how we're actually taking and monitoring these patients post-injury or in the lead up to risk of heart failure and heart disease.